Hi, everybody. So, who is here for the CIED program, the Corporate and Industrial Users program? Put your hands up, please. If you're not here, you're in the wrong place. So, everybody? Okay, very good. It would be helpful, we're going to start the first panel in a couple of minutes. I'll introduce myself, but prior to that, it would be helpful to understand. Firstly, if you want headsets, then you need to go and grab them over there, but I think everyone's okay. It'd be helpful to know who's in the audience, because that helps our panelists and our speakers understand the context. So if you're a large energy user, so a large corporate or industrial energy user, can you put your hand up? Okay, very good. Of the large energy users, how many of you would say that energy represents more than, I don't know, 10% of your cost of sales? So it's like strategic. Okay, very good. Second, which sectors are we talking about? Maybe shout out some sectors. Ceramics, you use a lot of energy. Metals, okay. Paper, uses lots of energy? Okay, very good. Well, chemicals, yeah. Any cement around? Steel, we've got steel, I believe. Airport, well, you're going to use even more energy when planes start becoming electric one day. Okay, very good. Other question I had, in terms of geographic presence. So how many people are UK, apart from myself? Let's say Scandinavia. Okay, very good. Central, Western Europe. Okay. Eastern Europe. Okay, and Southern Mediterranean. There's always got to be one. Okay, very good. All right, thank you very much. And in terms of the other people represented, so how many service companies looking to try to sell to some of those nice ladies and gentlemen who have just put their hands up? Okay, fine, very good. Energy suppliers? Okay, I guess including that is energy generators. Who wants to sell PPAs? Okay, that's him. Okay, he's the PPA guy. Okay, we'll know. What about consultancies, advisors? Any people? Okay, very good. All right, great. That sounds a good start. So let me introduce myself. My name's Jason Simpson. I'm head of energy for Liberty Global. So Liberty Global is the world's largest cable TV, international cable TV operator. So in some of your markets, in the UK, we're Virgin Media. In Germany, we're Unity Media. In Netherlands, we're Vodafone Ziggo. Belgium, we're Telenet. Switzerland and Central Eastern Europe, we tend to be Cello or UPC. So that gives us a bit of our background. We're a reasonably large user of energy, certainly not as big as some of the companies in the audience. For us, it represents in the European footprint just over a terawatt hour per year. So let's say significant or material, but maybe not significant. It represents about 5% of our company costs of OPEX. So we like to try and improve it, but it's not yet strategic, I would say. However, we have a lot of energy assets. When you're running a telecommunications network, a cable TV network, that relies on power. So it is critical. If we don't have power, then our customers don't have broadband, voice, internet, TV, and so on. So it is critical to us, and we're trying to optimize it. And I suspect, like a lot of corporate industrial users, we're seeing the costs of energy just go up and up and up. And that's not yet driven by commodity charges. As much as anything, it's driven by grid charges, taxes, and so on. So the challenge for us is, how do we do things now to try and avoid that at the same stage as become a more sustainable company? So that's a little bit our logic for why we're interested in this. I think this afternoon's session, it's really all about corporate and industrials starting to become prosumers. So previously, 10 years ago, as a corporate or industrial, the closest we could become to being a prosumer was generating our own energy on site, which some of the larger, chemical, cement, steel might do that. However, that was about the limit of it, and the rest of it was you bought it off your energy supplier, your utility, and you paid the bill. And that was that. Now that world has changed dramatically over the last 10 years, not dissimilar to the way telecoms has changed in the last 20 years. So this afternoon is about our role as a corporate industrial user in these new energy markets. So how is that transition happening, and what are the opportunities for us to play a role in that? But also, what does the, let's say, the context need to be for us to be able to be effective in playing that role? So what regulation, what help from advisors do we need? What role do the energy suppliers need to play? And all those things will help us be a good corporate prosumer or a less good one. And I think that really this afternoon is to talk in specific detail about some of those opportunities, whether it be flexibility, whether it be about price signals, whether it be about technology, and understanding some of the case studies of the companies we have around here in how they are being a corporate prosumer. We also have some very interesting presentations from some technology institutes and universities who take the nice story and actually analyze it in a deeper way. Because we're all given the pitch, it will save you 20% of your energy. This PPA for 15 years, it's going to be a great deal for you. Those grid charges, they're going to keep on going up. Actually, what is the reality when you start looking at it in the detail? Because as we know as companies, it's one thing selling it to our senior management, it's another thing, the business case, which you need to justify on that specific site in that specific location. So you'll see some of that today as well. We're going to start, however, with two organizations who represent large energy consumers in the Netherlands and in Germany. So I'll ask Hans and Barbara to introduce themselves. And we'll then, in effect, just have a panel discussion around what they see as some of the important issues that their members are facing. And interestingly, there's a few, when we discussed this earlier in the day, that I didn't even realize were quite so important. I'm keen for you to be, as an audience, proactive. So please, when you get questions in your mind, I'll give you an opportunity to ask those questions as we go through. So, do give me a hand sign or something like that, and I'll open the floor up anyway. So, I'll start with Barbara. So, Barbara, if you could maybe, take a second. Firstly, introduce yourself and a bit your background, just so everyone understands, let's say, the context of where you come from. And then maybe just give a couple of minutes view on what your organization's view are, some of the major challenges that they're facing in this new world that we're in.
Yes, perfect. Well, my name is Barbara Minderjan. That's the German surname. It's difficult to pronounce. I'm the director of VIK. It's, as I say, a federation of large energy users, which is industry, but not only industry. It is also other companies from other sectors, like we have transport sectors within our federation as well. We have some companies who are delivering services to these energy users, but mainly it's a large producing companies like chemical, steel, glass, cement, the whole range of branches. And that's really one of the most important thing and difference to other federations in Germany, because we have sector federations and we have the BDI as a big industry federation, but that's not focused on energy. We are. So we deliver or we talk about all energy-related issues and topics. We have about 300 members, and these 300 companies represent about 50% of the percentage of energy used in Germany by industry and companies is 50% of the overall energy. And our 300 members represent 80% of the energy used of this sector. So it's 40% of the overall energy and 90% of industry generation. So basically it is generation and usage from the market. Mm-hmm.
And there you're talking very much energy rather than electricity or any other forms?
It is both, yeah. It's energy and it's electricity and heat. Mm-hmm.
Okay.
Yep.
That's great.
So you've asked also for the focus of...
Yeah.
I mean, basically the main topics for our industry is really related to the government's decisions in respect to decarbonization. That's one of the topics which is of heavy interest for our companies, especially in that sense that with the given targets, the energy prices are about to rise. So how are these companies going to be economic, viable, and persistent in the market, especially in the global market? The comparison is not the German market, which would be easy, or even the European, which is a bit more difficult, but it's the global market. And the security of supply topic, price topic, these are the two related questions.
Okay, that's great. Fantastic introduction. Hans, maybe.
Thank you. Thank you, Barbara. My name is Hans Grunveld. I'm the director of the Dutch Federation of Non-Domestic Energy and Water Consumers. Like our colleagues in Germany, we are dealing with two topics, energy and water. And our membership is also very, very diverse. Of course, the energy-intensive industries, from the chemical industry, the steel industry, some of the other sectors like paper and pulp and food are represented, but also other sectors like, well, the airport industry is here, right now here, but also transportation in general, and some of the ICT members as well. Liberty Global, unfortunately not, but that's a decision which I don't understand. But
we'll come back to that.
Particularly because if you look at the challenges that our members are facing, by the way, we have a similar membership as our German colleagues. We have also about between 340 and 400 members. We've had a decline in membership over the last decade, but thanks to our current government, we see now a increase in members because the challenges that they are facing are actually increasing. Now, what are those challenges? Roughly, you can make a distinction between three major challenges. One is the decarbonization policies and objectives that the current coalition government in the Netherlands has, and that they are now trying to implement via a national climate agreement in which we are very actively involved. The second is for most people who are dealing with energy issues, the most important one, which is which has to do with market price developments, electricity, gas, CO2. They all have seen a steep rise in prices recently. I'm not talking about, let's say, the last month or so where we see a decline now. But if you look at the difference between now and the beginning of the year, that's we are living in a completely different world. The third challenge has to do with a topic which we're doing a lot of work on, which are the non-commodity cost for energy-intensive users, which have to do, of course, with the grid cost. Since grid operators are monopolists, we have a natural role in trying to limit the cost, make sure that tariffs are based on efficient costs and so on. But they also have to do with connections to the grid, with charges for renewables, and maybe even a specific CO2 tax for industry. So these are basically roughly the three areas, the main challenges for our members right now.
Okay, I don't think, I think they're all, I think you're probably very aligned in those thoughts, and it's the same issues that, I think most, corporate industrial users or large off-takers face. I guess the question for me is, and I'd be interested in how your organization see that, is on the one hand, I think we're all in agreement that we need to make energy more sustainable. We need to, even if Donald Trump doesn't quite agree, but we need to try and make, the energy transition happen. But on the other hand, as you point out, that can make our own companies, within our own markets or within the European Union, potentially less competitive against other markets. What is the solution, or what's the direction of travel that finds that balance between getting where we need to get as a planet or as a humankind, but balancing our own personal requirements for our own corporates?
Well, I think it starts with the realization that our country, but also the European Union as a whole, is not an island. We are highly integrated in the world economy. Our industries are. They sell products. Some of the products are commodities, so by definition they face international competition. And very few people realize that whatever you want in terms of sustainability of transition, you have to realize that there will be huge impacts across borders, be it because we have an open electricity market in Europe, or because CO2 emissions don't accept borders, and so that's where it starts. I think the second notion, which is very important, is the fact that the energy transition and the industry transition are two sides of the same coin, I would say. They have to go hand in hand. There is no energy transition possible without an industry transition, and vice versa. If you look at it from really closely, you can see that there are many opportunities for optimization, for cost reduction, but also in terms of solutions, you have to integrate the two, and you cannot look separately for solutions in the industry or the energy sector. And the third is actually the realization that if you want to achieve deep decarbonization in the industry, it's not you have to change completely the way you make policies. You try to make change happen, because we're not talking about incremental change anymore. We're talking about structural change, and for structural change, you need also different and more structural solutions. I think.
Yeah, I would like to add to that. I mean, that's basically the goal, or that's the challenge. I mean, given the targets we have, and given the climate, the Paris Climate Agreement, it is clear that these targets are not reached without the role and the heavy role and the heavy impact of industry. The industry, given its the way it's set up and it's worked, or it's set up in also in synergies with other industries, never had that goal. They never had the goal to actually take care of CO2. They had to look to be economically driven towards saving of resources, saving of water, saving of energy, because that's always has been a cost impact. But CO2 never has played a role up to now. So now we know that it does play a role. So the whole setup of industry has to change completely. And that doesn't, I mean, there are basically three ways of doing so. One is currently saving more energy as you can, or using the energy you have in different ways, like heat, which low heat you can't use in industry, but you can put it or bring it to other areas and use it for heating, for example. And to find more solutions of partners working together. That helps for the current time being, but it doesn't really solve the problem. To solve the problem, it means you have to either use CO2, which is emitted, and use it as a resource in other industries. Or it means that you have to shift your procedures and your technologies to non-CO2 emitting procedures. And that means you have to change your complete way of producing and the complete network of working industries, of how industries work together. And we know some technologies with which you can do that. Some don't exist for some areas, so you need F&E. You need a lot of money to change existing facilities, and it needs a lot of time. And the problem is that the new technologies, they are not viable currently. So basically, that puts a very large pressure onto the economic surrounding and on global competitiveness. And we haven't got any solutions to that yet. I mean, this is this is the discussion and the debate that we are facing, that we are having with the governments and with society. Because, as you say, society needs to understand that this is the issue, and it's not a question of will. The will is there. Industries have realized that they have to change and that they have to transform, but there is not a solution to their competitiveness yet.
Does that mean potentially that we're going to see energy offshoring, if it hasn't maybe already happened in some industries? Or do we think that there's a light at the end of the tunnel that made in Europe will mean made sustainably?
Yeah. Well, heavy energy users will evade Germany and will evade Europe, that's not a solution, because it is the core of our welfare. These industries are so integrated, they're within each other and within the whole economy. There won't be the economy we know without these companies. So it should be our goal in society to keep them ashore. And that's what politics is starting to understand. I think we still need a lot of more dialogue with society for people to understand, because it's not a solution if they just leave the country and go away. It won't be a solution for climate, it won't be a solution for economy, but still it needs solutions.
I would go even one step further, because I think, as I said, the energy transition and the industry transition are strongly interlinked. If you look at the main challenges for the electricity sector, the decarbonization, the huge investments in renewables, for the Netherlands it means basically investing in offshore wind, which requires again big investments, high risks. So what the investors are asking for is actually demand security of demand. Who's going to provide security of demand? Industry. For a electricity system which is largely based on intermittent renewables, you need a lot of flexibility. Where does the flexibility come from? Indeed, a lot from the industry as well. And also finding cost-efficient solutions. I mean, Barbara talked about new value chains, new models. For example, steel to chem is a typical example. Now, most of the steel mills are integrated mills and are efficient mills using their steel gases in order to make electricity. Now, that causes CO2 emissions. Now, that is a problem for the electricity sector, if you wish. The industry can help to solve those problems cost efficiently by actually using the carbon content of their waste gases, in this case, and using as raw material for the chemical industry. That is a long-term solution for the chemical industry, namely a sustainable feedstock solution, but also a cost-efficient solution for the energy industry to reduce their emissions. So I think the solution is really, the way forward is not to say, well, this is the end for energy-intensive industries in Europe, because we don't stop using steel and chemicals and fertilizer and these kind of products. We have an opportunity in Europe to make a head start and to start to integrate in a very efficient and very sustainable way. I think that's the way we are trying to look for solutions.
Okay, Hans, you mentioned non-commodity costs, and I think it's on probably everyone's agenda at the moment. Yeah, certainly for us, we're seeing non-commodity costs going up across the board, and we're seeing the share of our total energy spend as non-commodity. A couple of questions on that. One is, what are your members, what are your organizations, what are the type of dialogue that you're having on those non-commodity costs, and what are the important messages you're putting out there? And secondly, are potentially corporate and industrials losing out because, in effect, governments are reluctant to pass on those charges to, let's say, domestic residential consumers? And so who picks up the check? C&I. So a few thoughts on that, and then maybe Barbara, if you have to start.
Well, The question really is, I mean, this is a problem that the costs are rising in that sector. Currently, for the time being, a lot of the heavy energy users are exempted from some of the costs. And that is because, especially in Germany, we have the system of EEG, of financing the renewable energy in Germany. Large energy users are exempted from that. That makes a big share of their bill. What we see is we have a rise in transport costs in other topics, and there is no exemption there. So it ends up with the industrial users, with the consumers. There is a reluctancy in society to give more exemptions, which companies would need currently. Because they say that there's already a lot of exemptions and it's too much because it puts a heavy duty on the households and on the rest of the energy users. And plus we have a big gap between those who are exempted and who are not. I mean, there are industries, we have the share of which have a high cost in energy, but not as much that they will be exempted. They're just below the rate that they are exempted. And they are even shouldering more and more costs. So basically it's a heavy duty for acceptance of industry. It has put industry in a very, very bad light in Germany.
Okay, so it's keeping some of the benefits you have already rather than necessarily fighting for new ones.
Well, we should, I mean, if this continues, we have to find a solution for that, because especially those who are very exhibited to these costs, who have very high share, like in aluminium industry, they are very much at the limit where they can't bear it anymore. And so they won't be able to stay in Germany if that's the case. So there needs to be some solutions, but solutions which are quick, which would be more exemptions, is very difficult to argue for within German society and German politics, because there's not much acceptance for that.
Okay, Hans?
Yeah, I think we are. There are at least three ways in which we try to influence the non-commodity cost issue. First is a very basic one, which is that we have, lobbied hard for a framework in which we have a strong position as a so-called representative organization in all decisions on grid and grid-related issues with the regulator. So every decision that the regulator takes, we can actually take to court. We can go to court, and we do so, and thereby we have gained basically a seat at the table. People take us seriously, and we are, involved in these discussions. So, for example, as we speak, we're now making a big deal on gas tariffs, and the regulator cannot make these deals without us. So that's the first. The second has to do with the renewable cost. Back in 2013, we had our first energy agreement, and one of the elements in the agreement was a decision on the cost of renewables, so a cost decrease of renewables, a path, and we're doing now the same with the climate agreement. We say we cannot agree with any substantial increase of renewable power without a simultaneous reduction in cost. And we're not talking about 5 or 10%, but really, 45, 50% cost reduction. And the third has to do with the grid itself, the grid cost. A system based on intermittent power requires an extended grid, extended capacity. Now, the planning of that capacity is crucial if you want to contain cost. So actually, what we are trying to devise is a process in which grid companies can make their planning, their decisions on grid extension, as it were, better in tune with the growth of both supply and demand. So in order to avoid a situation in which there will be a highly congested system on the one hand, or a completely oversupply of grid for which the costs are easily passed on to the consumer. So at least these are three concrete examples of that.
Okay, that's great. Thank you. I'm conscious of time, so we have just a couple of minutes before we wrap up. I have one final question, but I'd like to give the audience a chance. Are there any questions in the audience?
Hi there. I'm Ivan from Wind Europe, representing the wind sector. Can you hear me?
I can now.
Okay. I'm going to stand up. So, Wind Europe already published a study about what is needed to decarbonize Europe's energy system as a whole. Euroelectric is doing that as well in November now. We have European Climate Foundation doing it, and we already see similar results already. And that is, if you want to achieve decarbonization, you have to electrify the industry. And I wanted to hear your thoughts on that, especially because now the European Commission is proposing a net zero carbon society by 2050. And I wanted to hear what kind of impact that makes on your industry.
Maybe up to you.
Well, I mean, if you look at studies which are existing already, there, first of all, what you see is basically, yes, you're right. Without industry, you won't be able to decarbonize. Hans mentioned a few issues related to that. As I said before, I mean, basically a lot of emissions are in industry, and we lose half of the of energy used in Germany is industry or economy related. So it is quite clear that without industry and economy decarbonizing, you won't reach the 2550 goals. The question is, there is a big difference between 80% and 95% and 100%. And if you look at the scenarios and the studies existing, which haven't taken the 0% road yet, but the difference between 80 and 95 is a complete change of our society, not only economy. I mean, economy has to change and to make a transition anyway. The question is the difference between 80% and 95%. If you look at the study from BDI in Germany, which has been done a couple of months ago, means that with 80% you can still use somehow some of the existing industries and infrastructure. With 95% you can't. But with 95% it also means that people will stop eating meat. It will mean that we will have targets on housing, we will have targets in traveling and all areas and sectors related. So you can imagine, if there is such a big difference between 80 and 95%, you can be sure that there will be even bigger differences between towards anything which is even more ambitious. But 0%, I mean, you still, when living, I mean, you still emit CO2, and animals do, and so on. And there are some industries which also can't work on a zero emission course, like cement, for example.
Yeah, we have looked at the first at a sort of high level at the Paris Agreement and the impact on the industry, and later on we zoomed in on the 2030 target that the Dutch government set. We did a study with McKinsey, and it basically looked at the potential in the industry. Well, if you look at the current objective of about 50% carbon CO2 reduction in 2030 compared to 1990, we see three major drivers of decarbonization. The first one is CCUS, so it's even carbon capture and storage or usage, which is probably needed to take about 50% of the solution right now. The second, which is a very important part, about 30% of the CO2 reduction, is electrification. So it's power to heat, but it could also be power to products, and ultimately things like electrochemical processes and so on. And the third is a change in feedstock and energy efficiency. It's a combination of the two. This is up to 2030. Now, why is this up to 2030? Because first of all, there is a concrete objective and policy by the Dutch government, but also because we don't have a crystal ball, and we know that, as I think Barbara mentioned it before, we need a lot of technology development in order to really provide the types of solutions that will bring us somewhere close to the 2050 targets. Take, for example, hydrogen. I mean, there's a lot of talk about hydrogen. Industry has a lot of experience with hydrogen. Yeah, there's a huge potential in hydrogen, but I haven't seen not even let's say a perspective of a good business proposal for using large-scale hydrogen. I mean, blue or green hydrogen. So it's clear that you need a different approach towards the different types of solutions. There are solutions that are basically out there, technology which is mature. You can easily apply it. Maybe there is still an OPEX cost issue which you have to solve, but at least you can start working. But there's also a lot of technology we need to have to be developed. So we need a lot of innovation, and we need, similar to the energy industry, a lot of cost reduction. So we need a lot of scale up, and in order to be able to reduce the cost of certain technologies. So it's and there's no one solution, one size fits all solution. So you need to work along those three axes, and that has the perspective to bring us at least halfway in 2030, and hopefully a lot further down the road afterwards.
Okay, we're going to wrap this session up. Before we just finish, last words to Hans and Barbara. In terms of the corporates in front of us today, apart from joining your organization or a similar organization, what would be in one sentence the thing that they can do to help the debate, help the discussion, help move the needle?
Well, I think the answer is very, very simple and very short. I mean, our members, the industry, others have a lot of knowledge, and they should bring in this knowledge into the debate. That's very important, because there's a lot of discussion about completely unrelated to facts, basically to reality. So we need the industry and other corporates to really get engaged, to stand up and make clear, look, it's sustainability transition is our challenge. We're working on it. We're doing a lot of things, and we like to engage in the debate, because it's not that we don't want to move further. It's because there are a lot of problems to be solved. We are in there, but we cannot solve them alone. So we need to be part. We are part of the solution. We are not part of the problem. We are part of the solution, and we like to join the debate.
I'm sure in Dutch that would have been one sentence. Thank you, Hans.
Yeah, I would like to underline and focus on one topic or one part of what you said. Be optimistic. Try to convey this optimism to society, making also aware or making them aware also of the challenges and problems. But start from the optimism and don't start from the problems, because that's what people don't believe from industry, that they really want to find a solution. And I think we need dialogue, so engage in dialogue.
As Obama would say, I can. Great, thank you. Can everyone show their appreciation to Barbara and Hans? Thank you very much, appreciate that. Thanks, Barbara. Great, so we're going to go from policy and communication and sharing knowledge to something more specific. So Daniel, if you can maybe, I'll help you set up. So you have a speaker there, unless you prefer to take a... Great, and yeah, so you can put that under there, and you have a clicker there to go back and forth. Okay. So, Daniel, if you could introduce yourself first and your background, so that everyone can understand a little bit about where you come from, what perspective you come from of this, and then all yours. And again, there will be an opportunity for questions at the end.
Thank you very much for the introduction. So, my name is Daniel Schwabenneder. I'm working as a PhD candidate and research associate at the Technical University of Vienna. And I want to talk to you today about the work we did on demand response in the European Horizon 2020 project, BestRES. So I will first start by giving you a small short introduction into this project. In this project we tried to investigate and analyze and improve business models for renewable energy aggregators, but we kept the definition of aggregators quite wide. So with aggregators we meant aggregators of renewable energy production, but also aggregators of demand, and we defined aggregators as legal entities that pool these units of demand or production and try to optimize energy consumption or supply, either technically or economically. In this project, we have a lot of partners. So first, the coordinator is VIP from Munich in Germany. There are the technical partners 3E from Belgium and Technical University of Vienna. Then we have legal partners, Stiftung Umwelt- und Energierecht from Germany. And URIS is supporting us with the dissemination. Furthermore, we have a lot of aggregators in the consortium that cover a lot of European countries. So we have Next Kraftwerke, which you probably know. They are active in Germany, in Belgium, in France and in Italy. We have Good Energy, which is an energy supplier in the UK. We have EDP, the Energias de Portugal, which is a supplier in Portugal and Spain. And furthermore, we have a research center in Cyprus, which is supporting us to bring the southern eastern perspective in the project. So what we did first, we tried in this project, we tried to develop improved business models for such aggregators. I don't want to go here into every detail. I'm not sure if you can read it from here, but what you can take from this slide, all those darker colored business models deal with demand response, and the brighter was deal with renewable generation, and from the darkest ones deal with the demand response of large industries, or medium to large scale industries, while the brighter ones focus on the residential customers. And I want to present today the results of our simulations that we did on two of the business models that deal with industrial demand response. So just I won't stick too long with the methods, but just to give a quick introduction, we used here a simulation library that we developed at our institute that allowed us to model all this and simulate all these different kinds of business models that have been developed. And now I will go to the first example, which focuses on the aggregator of EDP. EDP wants to use the flexibility of their medium to large scale energy customers to optimize energy procurement or reduce the imbalances. So I'm not sure how much you are aware about these imbalances, but balance responsible parties are obliged to match demand and supply, and if there are deviations from demand and supply, they have to pay imbalance prices. And for this we wanted to we defined two different scenarios. The one scenario is to use the flexibility of the customers to optimize energy purchase on the day-ahead spot market, and the second scenario is as I said, to reduce the imbalances of EDP. And then we analyzed the third theoretical scenario that chose the best of the two other scenarios each hour, but it is theoretically because we do not know beforehand how much the imbalance prices would be. Whereas for day-ahead spot market prices, we have quite good forecasts. So just to give a quick overview on the model scaling here, we considered here 3 different loads from different industrial customers. We scaled them all to the size of 1 megawatt, and we made different assumptions on the flexibility that would be available by these loads. So one load we assumed could be changed by 10% up and down, and we define something like an equilibrium period. So we deal with shiftable loads. If we increase reduction at some point during a day, we have to reduce it at another point in the day. And for the other 2 loads, we also had some restrictions on the number of activations per day and the duration of these activations. Here on this graph, if you can see it, you can see how the model in operation looks like. So at the bottom bar, you see indicated the market prices during the respective hour. The brighter this color is, the higher the market prices are, and the darker this color is, the lower they are. And as you can see, the 3 different loads react to these prices, and they decrease at hours of higher prices and increase at hours of lower prices. These are the flexibility activations of one example week in the spot scenario. In the imbalance scenario, we do not have any prices available. Here we only have the direction of the imbalance of EDP's balancing group. So if the bottom bar is darker, the EDP has a negative imbalance, which means there is more demand in the group than supply injection to the grid. And in the yellow areas, there is a positive imbalance. And these flexibility activations react to these imbalances here. Then we come to the annual results we got. So we used load and market data and imbalance data from the year 2016, and we simulated this all on a quarter-hourly basis for this year. And we see here the results in the 2 different scenarios. So what we can see is that the spot and the imbalance scenario achieve quite similar results. For these loads, on average, a cost reduction of about 2.4%. In the optimal scenario, if we would have information about the imbalance cost at the respective hour, we could more than double these benefits. So that's the first example that I wanted to show you. The second example is very interesting. It is about using the flexibility of an industrial customer as a third party. So what this is about is Next Kraftwerke Belgium. Probably a lot of you know it. They are pooling different customers and marketing them on different markets, but they always have difficulties to acquire new customers who already have a supplier which has quite competitive prices, but doesn't offer flexibility activations to their customers. So Next Kraftwerke would like to use their know-how on marketing these flexibilities, but they need to find bilateral agreements with the supplier to be able to market these flexibilities, because if they schedule flexibilities of their customers, this influences the imbalances of the supplier and also the cost, the revenue that the supplier gets from these customers. And hence, these bilateral contracts are required. So here again, as an illustration, the supplier and the customer are in one balancing group, and the aggregator who belongs to another balancing group only wants to use the flexibility of the customers for certain hours to sell this on different markets. And the issue is if Next Kraftwerke reduces here this load on the left bottom graph at this hour and sells this on one market, it influences it may create an imbalance in the balancing group of the supplier, and it also influences the load profile that the supplier is billing the customer. So a bilateral transfer of energy contract is required between aggregator and supplier, that in order that the supplier does not lose revenue from the customer, and this is often quite hard for Next Kraftwerke to achieve such contracts. Again, here you can see illustrated briefly the assumptions we made on 3 different loads and their flexibilities, which is similar to before. We restricted them to a maximum load change, different numbers of activations and durations per day, and also the lighting load we had here is only available at evening and night hours. We defined here 3 scenarios. So the baseline is just that no aggregator is involved at all. Flexibility is not activated. In the spot scenario, Next Kraftwerke is using the flexibility of their customers to optimize day ahead schedule. And in the reserve scenario, flexibilities are used on the tertiary reserve market in Belgium, so MFRR market. And for this, we use a diesel generator as backup, but load flexibilities are prioritized. And we assume, again, that these are shiftable loads, so reserve activations have to be balanced again, because reserve activations are not known before. And if the reserve gets activated, then the load has to buy this energy again that it has reduced. Yeah. So here we assumed here that in these scenarios that such a bilateral contract is in place between aggregator and Next Kraftwerke Germany. So between the aggregator and the supplier, so that the supplier does not lose profit from selling energy. So in the baseline, we are not looking at grid costs here, but only about the energy costs from purchasing this energy from the market. In the baseline scenario, on top we see the cost of the customer, and I don't know how good you can see the numbers from here, and on bottom we can see the profit of the supplier. So he gets exactly the cost of the customer and has to buy this energy that he gets from the day ahead market. In the spot scenario, we see that the supplier has the same cost because he still schedules, has the same day ahead cost because he still schedules the same profile of the customer, but he gets different revenue from supply because flexibilities are activated by Next Kraftwerke Belgium, and this difference has to be balanced out by this supply transfer, which is dealt with in the transfer of energy contract. And the reserve scenario is a little bit more complex. Here we have also, I won't go into detail here, but here we have the also revenues from reserve activations, costs from intraday rebuys, and imbalances caused in the supplier's balancing group. And all this has to be again balanced out in the supply transfer contract. As an overview, here you can see the benefits that this business model brings to the aggregator and customer together. So we have not defined a specific share, how these benefits are shared amongst customer and aggregator in these business models. There are different options for this, which we do not deal with here in our simulations now. But what we can see that in total, in the reserve scenario, more benefits are achieved, but most of these benefits are achieved by the diesel generator. For the flexible loads, the spot scenario provides better results. Then to a few short conclusions. So flexible energy demand can be used in various ways and various markets to generate benefits for energy customers, and aggregators with their know-how provide a possibility to do this for them. And we analyzed several different business models. The two are presented now. We also analyzed one for Next Kraftwerke Germany, where we also took into account the network charges in the optimization of the energy cost. And yeah, this demand-side flexibilization can result in win-win situations among multiple participants. Thank you for your attention. And
stay there. You don't get off that easily. I've got a question for you. Anyone in the audience have any questions? I know this is some quite complex stuff. I'll throw you my question first. So, does it mean that in the future model, if the energy supplier is also the aggregator, that therefore it improves the economics because you don't get the negative effect and the need to have that supplier aggregator back-to-back contract? Or is there still a role for an aggregator because of an additional part of the equation?
I mean, we identified several roles of aggregators in the project that an aggregator can take. We identified combined roles, like a combined aggregator supplier. I guess this was what your question is targeted. And here the aggregator is offering these aggregation and flexibility services together with the supply contract to the customers. But we also identified these independent roles where, as I said, in Belgium for Next Kraftwerke, they are struggling with customer acquisition because a lot of customers already have long-term contracts with energy suppliers that Next Kraftwerke cannot compete with, but these suppliers do not offer this kind of flexibility services, and that's why such third-party business models could be interesting for the customers in these scenarios.
Okay, understood. Any burning questions? We've got to find the speaker. Oh, there you go, the microphone. Not a bad throw.
I have one question. When talking about aggregations, there are always... Okay, sorry. Okay, when we're talking about aggregation of small loads, electric vehicles, microgeneration, there's always a key issue which has to do with communication. I don't know if it's something that it's part of the project or not. I mean, I'm aware that several projects such as microgrids, virtual power plants, was something, this decentralization is something key, and it's something very complex as well. I'm not sure if it's part of the project as well, or it's not a topic that has been treated. Thank you very much.
Yes, we have also dealt with this in other business models that I did not present here. For example, for Good Energy in the UK, they were dealing with so here the improved business model is really home automation and flexibility activation of small-scale residential customers. And here we were also dealing with these data communication issues. But it is a very, very complex topic, yeah, as you say.
Okay, Daniel, thank you very much.
Also,
indeed.
maybe as a final remark, you can visit our homepage, bestres.eu. Here you can also find a 10-pager of legal recommendations that our legal partners, Stiftung Umwelt und Energierecht from Germany made, which is very good summary of the barriers we identified in different European countries, and yeah, that's it.
Great.
Thank you.
Secret of success for getting European funding, make sure your project name is a good one. Daniel, thank
Thank
you
you
very much indeed. So while Thomas comes up, and I can help you set up. Okay, before Thomas starts, introduces himself, so of the CNIs here, who's got heat pumps? None of you have got heat pumps, I don't believe that. One, I've got one heat pump. Going, two, a second heat pump. Okay, who's in chemicals? Okay, well, fine. So you've got heat pumps. What other sectors? Everything.
Everything, yeah, we'll see that.
Okay, we'll see. So I suspect there are a lot more heat pumps around than you believe. So Thomas is going to introduce us to heat pumps and the importance. Even we've got heat pumps as a telco. Thomas, thank you.
Yep. So, does this work? It's good.
Technology.
Technology.
Good. There you go.
Okay, thank you very much for your introduction. My name is Thomas Fleckel. I'm from the Austrian Institute of Technology here in Vienna, and I'm heading a business or a competence unit about thermal energy systems, dealing really with heat pumps on different levels. And I'm also board member of the European Heat Pump Association, as well as the Austrian delegate in the International Energy Agency for heat pumps. Today I will talk about heat pumps in process industry, and I give you a short overview about my presentation. So I will talk a little bit about the potential, about the question why we should or could use heat pumps in industry. Then it goes also to the question how to integrate this technology into industrial processes. I will give you also, I think, a good overview about the state of the art and also an outlook about the technology itself, and talk about the process integration. And last but not least, I will end with some best practice examples coming from Austria at different levels in different industries where heat pumps are integrated. So, before I start with the potential, and as you asked this question before, I think it's also a little bit necessary to go to the principle of a heat pump, and this is shown here in this scheme. So the heat pump is a technology where you can upgrade heat energy from a certain temperature level to another level by investing somehow, okay, this is not working, some compressor work. You see this here on the picture. You have the heat input and the heat output, and the heat output is your benefit, and you're investing somewhere in this example 25% of energy for getting 100% output. And this relation is more or less the key performance indicator for a heat pump. It's the coefficient of performance at least, and this is coming from physics dependent on the temperature levels from the heat sink and from the heat source. And therefore you see it's also necessary, if you want to have a high efficient heat pump, to have a good idea about the integration in an industrial process. And what you see also here is, you see some temperature levels, which are, I would say, normal for different industrial processes. And you see here also the main components in the heat pump. The heat pump itself uses a so-called refrigerant, which is a chemical media, which is pumped more or less in a circuit. And this media is changing its phase from liquid to gas phase, and this change is used at the heat input side as well as the heat output side. And the heat output side, there is a heat exchanger, the so-called condenser. There is the refrigerant condensed, and then it goes over the expansion valve back to the evaporator, where the refrigerant is evaporated. That means the liquid refrigerant is then evaporated, coming to gas phase again. and then the compressor brings the refrigerant to a higher pressure level. So I think it's important because somehow we will have some wording about later in my presentation about the different components. And only 2 persons raised their hand about knowing something or having heat pumps. I know that, or assume that every one of you has a heat pump at home. At least the refrigerator works with the same principle. So refrigeration, air conditioning, heat pumping, it's more or less the same physical, the same principle from physics. So if it comes to some potential topics, I can show you here a potential study all over Europe. You see here different industries. So I think it's not only a question about the branch in industry. I think there is potential for heat pumps in every industry. You see here also different temperature levels. This is also important, not only for the efficiency, but also for the design and the maturity of the technology itself. And here you see there's a lot of potential in the really low temperature level and going up to the high temperature level. And coming from the wording, high temperature in heat pump terminology means 150 degrees C around this temperature. So this is not high temperature like industry is talking about high temperature. But you see here also relevant numbers in terms of energy in petajoules. So this is about Europe. So here in principle we can see that heat pumps have a huge potential for increasing the efficiency in industry. I will give you also some numbers coming from Austria. Here just a short overview about the final energy consumption. Industry is around 1/3 about the energy consumption, and there we can more or less install our heat pumps. We will not solve the decarbonization and energy topic with heat pumps alone, but they are, I would say, a main part of this transformation in the energy system. Here a kind of different view about different energy carriers in different industrial applications, and you see the biggest carrier is natural gas, but natural gas is not only used for high temperature issues, it's also used for steam topics, but also for low temperature issues. And I think this is also a good indicator when we want to do this transformation. We have to use on the one hand waste heat, but also create this waste heat up to come to steam systems and to substitute here the gas topic. What we have done in Austria was also 2 years ago a kind of roadmap. So we have involved all the stakeholders, industry, also the public stakeholders to develop a kind of outlook and also state-of-the-art review. How is the topic more or less in industry at the moment? You see here the numbers, which are not quite high, being honest. And there we have developed different scenarios how this topic can develop. There are different issues for these not so high numbers. One thing is that there are not really a long tradition in statistics in industrial heat pumps, and there's also a kind of overlap in between refrigeration systems. So it's not always clear what is a heat pump and what is a refrigeration system. But we have installed systems here, but they have also a really high capacity. So the message here is that we see a quite positive outlook, but of course there have been some frameworks that this can land more or less. I will go now to the part of the processes of the evaluation and also optimization of processes in more detail. When we ask the question where to use a heat pump in industry, if you remember the picture at the beginning, you need 2 sides. The one side is that you have to have really good heat source available. On the other hand, you need also a heat sink where you have the heat demand. If you're missing some of the sides, then a heat pump could not work, and of course it doesn't make sense. And what you see here, there are different heat sources like waste heat also from chillers, from refrigeration processes at 30 degrees C, waste heat from process cooling, which is normally get rid of by cooling towers, which is not used at the moment, 50 degrees C, wastewater, and also, and this is the last point with a really high potential, these are off-gas streams, maybe from gas boilers, flue gas, but also drying processes. Later on, I will show you more information about drying. And here we have high humidity and therefore a really high energy content in the gas, and this is a really good opportunity for heat pumps. On the heat demand side, we have also low temperature processes in industry, which are at the moment, and also steam processes fired or generated by gas or also biomass. So in future we have to use this with heat pumps, is my opinion. and we can use also heat pumps for preheating air or feed water. And what is also important, we need capacities up in the megawatt scale and in the megawatt range. Here this graphic is maybe a little bit confusing at the first sight, but I think it shows really good the potential of heat pumps. On the left side, you see in this graph more or less the heat supply temperature, so where you want to use the heat pump, from space heating up to district heating, low pressure steam, as I mentioned before. On the epsilon axis, you see the reduction potential of CO2 emissions in relation to the source temperatures. You can see. And this is important. This is also in relation to this coefficient of performance. And you can see also for really high temperature lifts for heat pump, around maybe 100 degrees C, you can also generate a lot of CO2 reduction potential. This could be of interest concerning CO2 taxes, as well as requirements from customers in the supply chain to reduce your CO2 footprint. The right picture show more or less the same thing regarding economics. We have different issues in industry. So the first side for checking the potential of a heat pump is the ratio in between the gas and electricity price. And this is more or less the relation also of this coefficient of performance, and this is the first indicator. The issue a little bit in industry is that you have different scales in industries and therefore also different electricity prices, somehow also different gas prices, and this scheme shows you independency of low and high electricity prices, also the demand of cost reduction. So it's only about the operational costs, not the invests, but the potential for large-scale industry is really about, I would say, a medium 50 to 60% of operational cost reduction. So this is, I think, also really important. And here also an example coming more from the research side. We know we have really complex systems somehow in industry, really in the big industry. There are different methods for the integration of efficiency measures. Maybe some of you know pinch methods to be used for optimize more or less all these heat streams and cold streams in a system. What we've done here is, in reality, you have not steady state streams. You have batch processes and so on, and we have developed the methods by mathematical programming to integrate heat pumps in really complex networks. And this is, I think, a really good thing because it has also cost functions behind it and can create the capacity of the heat pump itself. So it's also a support of the planning and design issue, how to integrate the heat pump. And we've compared this with state-of-the-art methods, and you can reduce more or less up to 50% of your invest costs by more optimized design regarding to the processes itself. So this is not a standard engineering tool, so this is just also coming from a research point. Coming to the technology itself, I will give you here a short overview. I think the first message, what is really important here, you see in this graph a lot of company names in there in relation to temperatures and also capacities. So this is not research. These are companies all over the world coming from Europe, Austria, of course, Asia, and different countries selling their heat pumps. You see the capacity is available and somehow also temperatures up to 150, 160 degrees, which are not so common at the moment in industry, but the technology is more or less ready somehow for from the producing side. What are the challenges for the heat pump itself, for the technology? I've called them research questions. You have on the first thing the refrigerant itself, so this must cover a lot of requirements, more or less. Maybe some of you know that we have an F-gas directive in Europe, which is in the direction of phasing out some of refrigerants with a low GWP, global warming potential. But there are solutions available like synthetic refrigerants, these HFOs, or natural refrigerants like butane or other hydrocarbons, also water for high temperature heat pumps. We need temperature resistant materials like sealings and oil for the compressor. And we need also some efficiency measures like ejectors, which can increase the efficiency in the heat pump itself. But also for the compressor, there are some requirements concerning cooling. But I think these things are technology, from the technology side, solvable, so this is not a barrier which makes it then a showstopper for the technology itself. And last but not least, of course, there are requirements coming from reliability and also short payback time from industry. So I think this is known. Here I want to introduce you a research project. This is the European largest research project led by IAIT. So this is going in the direction to demonstrate heat pumps in drying processes in industry up to 160 degrees C. We have two application sites coming from Austria, which is Wienerberger, which is the largest brick manufacturer of the world. I will show you later on how to integrate a heat pump in a drying process, and also Agrana, which is coming from the food production in the starch drying process, where heat pumps also make sense and were tested. So if you're interested in this, these prototypes will installed during the next year, and after this we have also a monitoring and results to show how these systems really work on-site in industry. Here a short few about these ejector topics. I see I have some German wording here, sorry for this, but the point is that you can use this ejector. This is a kind of nozzling system in the heat pump itself to increase the efficiency. I think this goes a little bit too much into details, but it should show you that there is also some room for improvement. With this part in the heat pump, you can increase the efficiency around 10 to 15% itself in the heat pump. So there are some further research questions. But as I mentioned before, I think it's really important also to talk about the process integration topic. Process integration means that you have also some planning and interaction topics in between multiple stakeholders. So you have on the one hand the technology provider. I've mentioned before, there are the companies here. You have the application side, and you have also in between the planners or the plant engineers, and they need also all the sides need some knowledge about the technology and also how to integrate and how to operate this technology. And this leads then to these topics, as I mentioned before, design optimization, operational optimization, and there are methods available to do this. Like I mentioned before, this mathematical programming, but also dynamic simulations, where you can also test controlling strategies and also the feedback loop on the process itself if you use a heat pump in your process. So it's not a plug and play thing. There are, I would say, in some process also some feedback loops to operate the process on different temperature levels, also with different parameters, that the system itself has a better optimum than the technology itself. Where you can integrate heat pumps, here's a really simple picture. We have in industry really also a lot of processes where batch processes go in the direction heating up, for instance, a tool or tooling in plastic industry or in metal industry, and then 5 minutes later you cool this down. And you can integrate here also a heat pump, putting this in the heat and the cold side. You can put in different machines in parallel, for instance, and there you have also some theoretical potential for energy savings, about 70% of energy consumption. I think more of interest is the drying issue I've mentioned before. State of the art, most of the drying processes work like this. You have a carrier, in most cases it's air. You heat up the air by a gas boiler, and the air is cooled down over the product and taking up the water, the humidity, and this humid air is going off the process and is therefore lost. And this is more or less the left side. And you can integrate also a heat pump there, and the difference is that the heat pump condensates the water in the steam and use this really high energy amount and bringing it back to the process itself. Therefore, you don't have any gas off, you have some water off more or less of the process, and theoretically you can reach up to 90% of energy recovery. In reality, we see in this brick drying process, we try to achieve 60%, but this is also really a high amount of energy savings. Here you see more on detailed how this works in the brick drying thing. At the top you see the state of the art, so you have the bricks in this drying chamber, and there is a heat supply and the burner and the exhaust air, and the humidity is lost. And with the heat pump, it's the bottom picture. Of course, it not only looks like it's more complex, this is the case, but you can keep in the air in there and only condensating the water and use this energy for heating up the process again. And here, some test results, really measured data. And here the message is, as I mentioned before, not only to go on an optimized heat pump itself, it's about the overall efficiency of the whole process. What you see here are different measured curves of the same heat pump at the same drying chamber with different temperatures and different parameters of the ventilation system over the curve of the drying curve. Yeah? And you see the error, and if you go to the left picture, you see the coefficient of performance, so the black curve would be the high efficient operation point for the heat pump itself. Yeah? And on the right hand side, the diagram shows the overall efficiency over the whole process, and there you see it's not this process where you have the best efficiency, it's the process where the error goes there, and this is only a medium coefficient of performance. So you need really the holistic approach to find here a good optimum. And with the same system, you can increase here or decrease the efficiency around 25 to 30%. So if you don't have this or don't see this, then you can make a lot of mistakes by the integration in an industrial process. So I come to my last chapter, which is about examples. So here you can see different examples in Austria. Maybe some information to this if you're interested in more examples. We have done this during the last 5 years within the International Energy Agency all over Europe, also with Japan, some other Asian countries, to show what are the best practice examples in industry. So this is, I think, also a really important point, and I think I have 4 or 5 at least examples. First is in the food industry. What is here of interest is we have here medium temperatures. You see a picture how a heat pump look like. We have a capacity around 800 kilowatts of heating capacity, a natural refrigerant with CO2. This was installed this year, so this is really a new application. If it goes then to steel industry, this is a project, also really a young project with really high capacities. This is done by a Swiss manufacturer, so they are building really the highest capacities. This is used to use the process water, the waste heat from the metal industry for district heating in Graz, the second largest city in Austria, and can really create a large amount for the district heating system over the seasonal performance of the system. So this is really I would say, good application, not in the process itself, but using the process for the supply of a district heating system. This is an example coming from the plastic industry, installed in 2010. So this system is running some years, also with moderate temperatures, but this is a process integration showing that there are also lower capacities available, around 100 kilowatts of heating capacities. And last but not least, this is a project not directly related to industry, but I think it's worth to talk about this. These heat pumps are installed here in Vienna, in the connex with the big power plants in Simmering here, also for heating supply in the district heating systems, and they will go into operation until the end of the year. That's the plan. And have a look at the capacity. They are really also in the high megawatt scale. So at the moment, as I know, they are the really biggest installed heat pumps in mid-Europe at the moment. So that was also my last slide. Thomas. Thank you for your attention. And
thank you very much. Stay up there. If you have any questions, get them ready. For me, it seems like a no-brainer. I mean, we can see the efficiencies that in those type of processes are. It ticks lots of boxes. Yep. So what are the reasons that maybe companies or processes, don't use heat pumps? Is it technology? Is it investment? Is it understanding or complexity?
Yeah, I think it's all what you mentioned. So what I've seen over the last years is that it was not clear that heat pumps can go to higher temperatures. So therefore, there was also this research topic launched, not only here at Austria, but also in several European countries, going also to this demonstration way. That's the first point. The second point is a lack of experience for planners, but also for the end consumers in industry. I think, therefore, it's also important to have these activities showing the best practice examples. And of course, there are always some issues in relation to framework conditions, in terms of what are the electricity prices. And what I see, for instance, you've seen some companies where we install the heat pumps. They are international companies, and it makes a difference for the same technological solution in which country you can install this and where not. It's not a unique market in Europe about energy prices, and I think that are the main the main reasons for this.
Makes sense. Any final questions before we wrap up this session? Okay, Thomas, thank you very much indeed. Every time I eat a Vienna sausage, I will be thinking of your heat pumps.
Perfect.
So we talked earlier about the importance of the steel industry in Europe, and about this concept of competitiveness. You know, if we're trying to be sustainable in the European footprint, how do we remain competitive in a situation where other markets may not have quite the same carbon legislation, etc. So Johan's going to introduce us to some alternatives that the steel industry is looking at around how it becomes more sustainable and reduces its energy.
Good afternoon, ladies and gentlemen. My name is Johann Brammer, and I am responsible for the strategic environmental management at voestalpine Group, and I am located in Linz, in Upper Austria. I really appreciate the invitation to today's event and in order to share our perspective regarding the decarbonization of the steel industry with the example of voestalpine. Okay, it works. Let me start with a very brief overview of European steel industry in order to give you an impression of key facts and the importance of this sector. At 500 locations in the EU, we produce approximately 160 million tons of steel per year. That's around 10% of the global production of steel. Steel is a key pillar for economic stability, social welfare, innovation, and last but not least, environmental protection. Only to mention some highlights. We directly and indirectly employed 2.5 million people across the value chains and in related service sectors. Create nearly 130 billion euros of annual gross value added and have substantially cut CO2 emissions and energy use over the past decades. As the only material that can be fully reused and recycled, steel is clearly a key material for energy transition and low-carbon society. These are figures of a case study of Boston Consulting Group on behalf of the German Steel Association. The illustration compares the CO2 reduction potential of steel application for energy and mobility with the emissions in their production. The result is a 6-to-1 ratio, so simply speaking, the use of sophisticated and innovative steel applications save 6 times the CO2 that is emitted in their production. The current situation. Before we talk about the future, let me briefly describe the current situation of the steel company and the challenges we are facing with. First of all, I want to clear up a widespread misunderstanding right at the beginning. The equation less CO2, less energy does not apply to steel industry. We cannot simply change the plug. We have to fundamentally change our entire energy management system and production technologies. We have to replace the fossil energy equivalent with external renewable electricity. Now we are using coal. With the example of the 2 voestalpine steel production sites in Austria, we are taking of 33 terawatt hours or more than 30 Danube river plants. The European steel industry, the dimension for full decarbonization would be 500 terawatt hours. So why is that? What are the specifics in the steel industry? Fossil raw materials are required for the conventional blast furnace steelmaking process. There's yet no other way in this route to get, simply speaking, the oxygen out of the iron ore. The energy contained in our process gases is transformed in our own power plants into electricity. This makes us largely self-sufficient with electricity to more than 80% and mostly independent from the external grid. This slide shows the energy cycle and flows in detail. But don't worry, I want to explain in detail. From heat to various process gases and cooling water, whenever it's technically possible, energy is captured and reused within the production and the processing processes. That means we have a high optimized energy efficiency in our plants. On some locations, we even supply the district heating system of neighboring cities or villages. So far, for the current situation. Steel industry in general, and voestalpine in particular, is committed to climate protection. We have to develop entirely new production technologies, mainly based on the utilization of hydrogen. But it's not only a long-term challenge for R&D, broad-based implementation must also be commercially competitive. However, we cannot do it alone. As mentioned before, and I would like to repeat this point, the fundamental transformation of the entire energy system, as we know it today, is a precondition for successful decarbonization steps of the energy-intensive industry. It's about partnership across and within sectors, and it requires, above all, a European solution, not only a national solution. What is the future vision of the steel industry, and voestalpine particularly? There are a number of approaches, and I suppose in the future there will be a mixture of these concepts, mainly of carbon direct avoidance, CDA, and CCU, carbon capture and usage. The best way of dealing with CO2 emissions is simply not to produce them in the first place. This is why voestalpine is focusing clearly on carbon direct avoidance. CDA approaches are based on the use of hydrogen, that's green hydrogen, which is produced with renewable energy sources. We are consistently pursuing our concept of step-by-step decarbonization, and we have already started the transformation process at voestalpine. We are currently already operating a bridge technology in our direct reduction plant in Texas. In the first step, we have shifted from coal to natural gas with the option of gradually introducing green hydrogen in the future. We are consistently pursuing developing and realizing a transformation path, as mentioned before, is not a short-term challenge. The illustration gives you an indication of the transformation period from today until 2050 and the detailed steps we are planning or already taking. Until around 2030, the focus is on the development of new hydrogen-based technologies, following by a period of implementing them in the long term on large industrial scale. In the meantime, we will do our own homework in research as well in metallurgical and technological development, but in addition, this is the time for the energy transformation I mentioned before. When both tasks are completely effectively, then the base for the transformation or the decarbonization of the steel industry is possible. Transformation to low-carbon steel making in the coming decades, however, is not for free. This illustration is only intended to give you an overview of the individual steps from R&D to full implementation of the new technologies in the years to come. The most cost-intensive part is not the development of the technologies, not the R&D, which is to a substantial degree supported by national or European funding. It's mainly the upscaling from demonstration to large-scale operation plants at the example of hydrogen metallurgy, the steps from virtual grams to kilograms, and finally to millions of tons. For example, we are at voestalpine, we are producing 6 million tons of screwed steel in Linz alone. And last but not least, the most crucial step we will need to plan and build completely new plants in Linz and in Donawitz. And this is the largest part of investments with around 7 billion euros. You can imagine that this dimension do not allow a wrong timing or the wrong technology decision. Furthermore, this requires a 30 billion investment in upgrading the system and infrastructure for green energy supply. This figure is for Austria's steel industry alone. After the investment, let's have a further look, or a short look at the production or operational costs of breakthrough technologies. Calculation shows us that the transferring to breakthrough technologies will almost double our production cost. So even if we won a lottery jackpot in order to finance the investment shown before, we would simply not be competitive due to the high production costs. And if the energy transition would be made only at the cost of a higher electricity price, this would clearly be the wrong approach. We must achieve cost parity between current and future technologies. Otherwise, it will not work. Let me give you an overview of our hydrogen projects. And I promise I don't want to bother you with too much technical details. Our CDA approach, carbon direct avoidance approach, consists of two pillars. An electrolysis demonstration project in Linz called H2 Future, and a basic research project in Styria for a new hydrogen metallurgy that is for hydrogen plasma smelting direction called SASTI. As the EU flagship project H2 Future is very present at this event. Thanks to the coordinator Verbund, I would like to tell you only the key highlights of the project. Today, hydrogen is mainly produced via steam reformation from fossil fuels, most natural gas, and this leads to substantial CO2 emissions. The vision of H2 Future is green hydrogen. Water electrolysis via electricity from renewable energy sources will become the main source of hydrogen with basically no carbon footprint. The project partners are technological partners, plant builder, and the science-based organizations. It's a little bit too slow. H2 Future is currently the world's largest and most advanced electrolysis project and of its kind for the production of green hydrogen. Start of operation will be in spring 2019, start of next year. This is the SASTIL project. As I told you, here can you have a look to this labor project, but I will skip that and go to the summary because time proceeds. What are the real success factors? The real success factors for success of the transformation process. First of all, sufficient availability of renewable energy in various forms, electricity, hydrogen, for all sectors, for mobility and industry. Secondly, renewable have to be competitive, especially when it comes to operational costs, compared to non-European competitors. The third factor, R&D and innovation, seems to be the smallest problem, because we as an industry have this more or less in our own hands, and that's our daily business. Other critical issues which has to be discussed. Who profits, but above all, who will have to pay for the energy transition? Which business model will prevail? At what costs? There are some sectors that cannot simply pass their costs through the final customer, and worse, they do not even create added value by producing the same product with only in a greener way. The quality of the product will not be improved. These are the issues that have to be addressed and coordinated on a multinational and at least European level. And on a political level, there have to be made some decisions. Who answer these questions? What is I would say what we need to make decarbonization realistic and successful? As I told you, we cannot do it alone as steel industry. A fundamental transformation of the energy system is necessary, and we have to remain competitive as an industry and as the European Union in general. We need ambitious, but at the same time realistic plans, because additional renewable energy is required for all sectors, not just for the industry. So I think I finished already. That's the last one.
Okay. Johan, firstly, it's a fascinating presentation. I wish we had the answer around this table. I mean, it's such a small problem.
You're right.
Exactly. So what I think is fascinating about this, I mean, clearly, the steel industry is of strategic importance to us as a continent and so on. And today, if I understand it correctly, we have steel production plants co-located next to basically coal generators in order to provide the energy. And in this future world, if we want to deal with decarbonisation, and here we've talked about hydrogen, we're going to need significant amounts of capacity, electricity capacity, to create that hydrogen for the process. So that leaves us two options. Option one is that we have to extend and beef up, or let's say improve the grid connection to those steel plants. Or option two is that we either relocate steel plants next to wind farms, or relocate wind farms next to steel plants. Which way do you think it will fall? Do you think we're going to see, the grid will have to, increase its capacity for those locations, or do you think that, some form of renewable energy will be, let's say, generated on site?
From my point of view, we cannot solve the problem only with enlarging the grid and only with electricity. We have to think in a broader way from the energy supply, for the energy supply of the future. We have to find solution that we heard today, I think, power to gas. That means we have to harvest energy, renewable energy, in region where it makes sense, where I have a high efficiency, wind turbines or solar. And then we have to produce gas, and we have to distribute the energy to the locations, to the steel industry, for example, or the energy-intensive industry where they are located at the moment, to have a cost-efficient way and to supply the system with renewable energy. And that's, from my point of view, the way which could be joined. Yeah? And this should be a way which should work.
Okay, very interesting. Do we have any answers, any questions, should I say, in the audience? I know what you're going to say. You're going to say, can you buy PPA off me? No.
Not really, but it's a good idea for start. So I'm even from Mid-Europe.
Can we speak up a bit and maybe a bit?
So you can hear it, okay. And we work quite a lot on how to connect the industry with clean electricity. So we are really proud that you are asking for more renewables, and it's already happening, for instance, in the Netherlands, where we are seeing pilot projects from offshore power plants producing hydrogen there, and then it's being shifted to the industry. What we saw so far was that different sort of industries, so the paper, steel, cement, they usually have one criteria, and I wanted to see with you, is it the same? It was the price of electricity on the wholesale market. So this was their main criteria if they're going to switch to hydrogen. So I think for steel, I saw something if it's below 35 euros per megawatt hour, and then it goes on for different industries in such a way. So do you think this is the main criteria in addition? And I agree, for more R&D for hydrogen and such technologies are necessary.
I think we have to put all effort in improving the or developing the new, I always say, the energy supplying system of the future, because if we can keep the energy price at a competitive level, then it will work, and then it's the chance that we can use our new breakthrough technologies to produce green steel. The most effort has to be put into R&D for energy supply, green energy, as I told you, power to gas and all these things. The other things are our homework. We have to develop the breakthrough technology to use hydrogen for making steel. But that's not the real challenge from my point of view.
Hello, good afternoon. Rolf Saman from Borealis. I have a question. I saw the slide in which you actually showed what it would cost to evolve to these disruptive, new technologies. I think it was number 18. I was wondering with what carbon price did you calculate there? And in addition, do you have, let's say, internally and in the company, a carbon price to valorize the business cases of future business models?
You have to know the European Union or the European Commission. The European Commission recognized in the meantime that for energy, for global playing energy intensive industry, the emission trading system, that means the carbon pricing, is not the suitable instrument to transform. Therefore, we get a lot of, let's say, free certificates, free CO2 certificates, to be protected against steel flow from China to Europe or wherever, or from this region where there is no carbon cost burden. But a small amount, not so small, I would say 1/3 of all carbon dioxide emissions we have to buy at the market. And this is at the price of 20 euros, you can say, for a first Alpine alone, approximately 90 to 100 million euro. And with 90 to 100 million euro, you can't find cost parity between the technologies. And that's the real problem. If you want to use the carbon price to have cost parity, you would need a carbon price much higher than 150 or 180 to 200 euros per ton. And that's impossible, because otherwise you have the problem, you wouldn't be competitive to current technology. And the market will not pay for this product, because he will buy the product from these regions where there is no carbon burden on the steel. And that's the real problem we have. That means the carbon price is not the right element, I would say, to force the transformation of the steel industry. We have to find other solutions, but I think the European Commission recognized already, and therefore there's the so-called carbon leakage protection in place, and this is very important to can survive as energy industry when you are a global player on the European level.
So I think in a Trump world of Twitter, he'd have been saying steel industry lobbying for higher carbon prices. Anyway, there was another question around Miles.
Hi, I'm Miles Alexander from STCL. I was just wondering to what extent you're using your off gases. So if you're producing coke, I don't know if you produce your own coke, and whether you're using that because that's got a high calorific value, or whether, basic oxygen steel making, whether you're using that as well. Because that's kind of free energy which you've got, which you could be recycling and reusing to generate more energy.
We are using already all process gases, from the coke oven plant, from the blast furnace, here you can see it. Yeah? Each joule or each joule of energy we can collect, we are using in our processes. Therefore, we are operating our own power plant. No, this doesn't work.
Yep. Okay, on the top right.
And we have a really high efficiency, and from this perspective, we could reduce the energy demand for producing one steel. In the last 50 years, we could cut to half of the energy demand we had 50 years before. And we also have had improvement for the energy efficiency in the last 2 and 3 decades, approximately 15%, I would say. This is also using waste heat and whatever. But process gas, we only less than 1%. We can't use due to security or safety reasons. And at the end, we are really very close to the theoretical minimum of energy we need to produce steel, because it's a chemical process. Iron ore is FeO, and you need to pull the oxygen out of this iron ore, and that's the theoretical minimum due to physics and chemics that you have to use, and we are very close to this theoretical minimum, and therefore no further improvements with energy efficiency or whatever is possible. I would say approximately, let's say, in the next 10 years or 15 years, until this time, when we will start to transform our processes from carbon-based to hydrogen, that means until 2035, maybe we can, in the next 10, 15 years, additionally improve the energy efficiency by, let's say, 5%, using low temperature energy and. But there is no more possible.
Okay, great, thank you.
Johan, thank you very much indeed. Welcome. Appreciate your presentation. So we have a panel next up talking about energy sourcing in Europe and PPAs. So maybe if Rolf and Remco, great, coming up.
Thank you.
Grab a seat. Okay, while we take that quick overview of the European steel industry off the table, I'll tell you what, let's swap around. There's a microphone there.
Yes.
Can I give you that one?
Thank you.
Can everyone hear me okay through this? Yeah, great. Okay, so I'm going to start with Rolf. So Rolf, if you can maybe introduce yourself, Borealis, and a little bit, in terms of, as a corporate off-taker, what size you are roughly, what are the things you're thinking about now?
So good afternoon, everyone. Rolf Samman from Borealis. So we are a chemical company. We're producing polyolefins, olefins, and fertilizers. And obviously, we are also big energy consumers, both in terms of feedstock as in terms of utilities. So in terms of powers, we are around 3.5 terawatt hours yearly, European scope. And
how many?
3.5. And for natural gas, about 20 terawatt hours. And this is mostly feedstock for the fertilizer business.
Okay, very good. Remco, you're in a very different part of the market, but also looking at renewable PPAs or off-taking from a different perspective. Introduce yourself and where you fit in.
Yes, so my name is Remco Frenke. I'm a Dutch guy, as you might see. I'm working for Priogen. That is a trading company. And I always say it's a risk-taking trading company. Things we are doing is going long 1,000 megawatts in Germany for next day, or 500 megawatts short in Netherlands for next day. Those kind of things we're doing based on models. In addition, we're also taking renewable risk. And that's, I think, the most relevant for this corporate PPA. To give you one example, we buy all the output from a wind farm for the coming 3 years for a fixed price. So we take the shaping risk, the forecasting risk, the price risk, all those kind of stuff. They are risks we are taking. That's what we're doing at the moment in Priogen. A little bit about myself, because it's also relevant for this discussion. The previous 5 years I've been a consultant. And in that role I advised several chemical companies on their green purchasing strategy. And also the main Dutch railroad operator on a green purchase contract. It was a 1.4 terawatt hour per year contract for 10 years. That was one of the first real large green PPAs in the Netherlands. So I would claim to say I know the trading side of things, but also as a consultant I've worked for the industry and I at least have some idea of the perspective in the industry.
Okay, thanks, Remco. So I'll stick with you for the time being. How would what's your view on where the European, let's say, PPA market is at the moment? Obviously, a lot of this stuff started in the US, and a lot of the big, deep-pocketed technology companies started, moving the needle on purchasing green power, renewable power. That started to come to Europe partly for their requirements, people like Google and Amazon and Facebook, but also European companies are starting to get on the bandwagon. How do you see the situation as it stands today, and how do you see it evolving in the next couple of years?
Yeah, thanks for the question. So what I see at the moment is that the green PPAs are very popular in Scandinavia, the UK, and in the Netherlands. Less so, in my experience, in Germany, France, or Southern Europe. Why is that? Because partly it's coming from the United States, so we're probably coming in from the West. Yeah? But also it has to do with the guarantees of origin, which are used as the key measure of having green power. And for example, in a country like Germany, all the guarantees of origin go to the state because they subsidize the wind parks. It also gets the guarantees of origin. Scandinavia, Netherlands, UK, it's a different subsidy system. And the guarantee of origins stay with the windmill owner or the solar park owner. And now if you're an industry and you want to show to your clients, to the Dow Jones Sustainability Index, to all your stakeholders, that you are enabling the energy transition, you want to have a line of sight from the wind park to your site. And we do that by buying the commodity power, but also buying the guarantees of origin. But of course, the guarantees of origin need to be available. And that's why it's not a success in Germany, but it is a success in the Netherlands, Scandinavia, and the UK. So I clearly see the trends because we're heading for subsidy-free windmills and subsidy-free solar, meaning this trend should continue. And the other thing is the awareness of the energy transition and the role the industry has to play is also increasing. So that also means an additional demand. There's also one problem, and then I will stop, before otherwise it's not a discussion. Industry is only 1/3 of the demand in Europe. Yeah? So if you want to get to 100% renewable supply in Europe, industry at most can do 1/3. The other 2/3 we have to do as private household or as shops, just to not put all the burden on the industry. Yeah.
I think that's a good point. It's interesting you say it is market by market because you can see the speed of progress is definitely markedly different across the markets. Rolf, from your perspective, what is your, let's say, Borealis' overall energy procurement strategy, and how does already, or how is it planned to, PPAs plan to fit into that strategy?
Yes, exactly. A bit framing what we are doing here exactly. So we started, let's say, the journey into getting more sustainable in 2014, where we decided to invest in 4 wind turbines in one of our sites. And a bit parallel with that, also building a 200,000 tons waste to energy plant at one of our sites. So, but more and more we start realizing that to really make an impact, we don't have enough space. And basically it's not one of our core activities to be active, first of all as an investor, but also as an operator in energy and utility production. And that's why actually we start looking now into PPAs to further, let's say, work on that progress and that journey towards more renewable energy. And this is actually something which we are now trying to draft in a corporate strategy, which is still to be approved, and then we hope to have actually an ambition level towards 2030 to really increase the level that we have now in the company.
And when you look at PPAs, for example, as a corporate, as a mechanism to going renewable or sustainable, and you look at at the best way of procuring those PPAs, what are the issues that you see in the marketplace? What are the challenges that you see? What are in order to get you from where you are today, as in, okay, we'd like to do this, to a point in 5, 10, 15 years when you've done some deals, what are the challenges?
I think a real success factor here is to avoid greenwashing. There has been a lot of greenwashing in these, let's say, in this business, and we really want to send a credible signal to all stakeholders. So that's why we are looking into physical PPAs, actually in the markets where we are active. Okay. And that's, let's say, quite lucky for us. We are mostly active in the Nordics, which is quite a major developed PPA market, but also a bit in the Netherlands and Belgium, and these are markets that are more and more coming up in offshore wind, for example.
And does financial risk, play a part in that thinking? Because, as you say, it's nice to be physical, it's nice to be, additionality, but in effect, you're taking on a long-term, quite substantial financial commitment. How does that fit into your thinking?
Well, we already have, let's say, a mid-term hedging strategy in place, so we take some price risk already. But yeah, of course, this will require us to look on a more longer-term scale, probably 10 to 15 years. And this is actually the mandate that we are requesting now within the company. And until now, I have to say this was quite well received. So we're on a good track.
Okay, great. Remco, you're all about risk, apparently. I mean, I don't know how you fit into the sort of the value chain from developers to investors to project owners and then to corporates. But is part of what you're doing taking out some of that risk for the corporates, or you're just playing in the market space, more the wholesale space?
No, we are taking part of that risk, and let me give the example, also a little linking back to industry buying wind and solar. Wind and solar goes like this. You, of course, are dependent on the wind and solar, how it basically is generated. Your demand is probably a baseload demand, or relative close to a baseload demand. So what you need is two things. You need the shaping from the wind spill output to the baseload. And that's what you call the shaping conversion. That's something my company is doing. But also, you have the fixed price risk on the baseload. And that sounds easy, but it's a very complex risk. Why? The shaping costs are a few euros. So if you're off, you lose a few euro or a few terawatt hour, it's a few million. It's relevant, but a good company will not be buzzed by that. If you think about the base load, and there you're wrong, you can be off by 20 euros for 10 years, for a terawatt hour. Well, you have to be pretty strong to survive that as a company. So what you see is that this risk, the shaping risk, more people can take it. But this fixed price risk, it's really something where you indeed would expect industry to step in, but I'm also very aware of the risks which industry is then taking on themselves.
But I think I can build a bit on that. The risk we are also facing as a global company producing commodities is, of course, that we face international competition. And taking such a risk vis-à-vis others peers and, let's say, competitors in others, China, let's say, or the US. Of course, this is a real risk, and if you're off 20 euro, that can hurt actually.
It's interesting. I mean, we're starting to see some quite innovative mechanisms coming out. So Microsoft just done a deal recently where they've coupled insurance to their PPAs. We saw a deal in I think it came out of Denmark, where the energy supplier, so the utility, so to speak, actually fronted the deal, or let's say act as an intermediary between the off-taker and the developer, which protected some of those risks, for example, around baseload, or let's say increased some flexibility. And for the energy supplier, it was no big deal for them because it was a relatively tiny amount of their whole portfolio, whereas for the corporate, that just took them across the line because they had that comfort. Okay, in going back a little bit to, you talked about this being part of the sustainability, and you can't just greenwash, and I get that. For big companies, like ourselves, I think we can afford to kind of learn the business and deal with relatively complex transactions. How do you see that changing for companies that that may only be using 100 gigawatt hours or 50 gigawatt hours, and what's the role of bigger companies in helping that market evolve, making it more liquid and driving development of new projects, but also what's the role of companies like yourselves in maybe whether it's aggregation or whether it's taking a little bit of the risk out?
So I think you mentioned 100 gigawatt hours. That indeed would be, based on my experience, the threshold where you really make this tailor-made green PPA, or you start more going to standardized products. And in my view, there still is a role for the, I would call it conventional utilities, because those guys can build the wind parks at sea and convert this into more or less standardized products for those, call it 50 gigawatt hour per year consumers. Some of those consumers might want to, let's say, have more skin in the game, and they want to do it want to make it tailor-made, and they could come up with a niche player like us. But then you really know they come to us because they really want to understand the whole value chain, and we can also do it for, call it a 50 gigawatt hour. Below 50, it's really hard to make anything tailor-made in the current market. So that's my first answer.
Yeah, it's probably in the first stage that the big companies actually need to move into this PPA market, making it more liquid and actually allowing the smaller companies to also enter.
And going back to the fact that you've got an international footprint, even within the European footprint, you know, there are multiple different energy markets. If you do want to be, you know, try and, you know, provide that additionality in your local market, etc. How are you looking at that challenge that you may not have the right level of consumption in one market versus another, or that, you know, one market may be a great place to do, you know, to buy into renewables and PPAs, another market that, yeah, it might just not be developed enough. How are you dealing with that issue?
Yeah, I would say we're still struggling with that question. As a first answer, we're saying that we want to make a difference in the countries where we are active, to really have that local, image stick to it. That's important. But of course, we realize that in some countries the market is not liquid enough to do something. But then again, I think the whole strategy is based upon a long-term view and a gradual approach. So we are looking into 2030, 2040, even 2050 now. And that means also that gives us some time to really gradually build that portfolio and not all of a sudden starts procuring, let's say, power from 200 wind turbines in the North Sea. That would be really, we're seeing this as a step change and not as a disruption.
Okay, all right. If there are questions in the audience, start showing your hands. We're having a good conversation here. I'm going to give away my control.
I would like to ask sorry? Oh, sorry. I'm Stefano Laimo from GME, the Italian Energy Exchange. I would like to ask what's about the counterparty risk in PPA? I mean, the seller, how they can guarantee from the counterparty risk of the buyer? Thank you.
That's a great question. It's very topical at the moment.
So it's a very relevant question, especially if you talk about long-term deals. Yeah? So let's start from the windmill and basically end up at the big industry like Borealis. So for the windmill, he needs a contract to show to his bank. And the first thing the bank will ask if this is indeed a credible partner. Is this indeed a credible off-taker for the coming 10 years? To do that, the bank will look at what's this off-taker taking for kind of a risk. Is it taking the outright baseload risk? And then it will think about a €20. Or is it only taking the shaping risk, and is it more or less buying at an index? If it's only shaping risk and buying at an index, reasonable credit is typical okay. Why? Because if the deal falls through because the counterpart goes bust, you know the deal will be more or less at the money. You could be off by €1 or €2, but that's not your biggest problem on such a moment. If it indeed is the fixed price risk, it basically becomes crucial to have a guarantee from the big insurance companies, a surety bond, those kind of stuff. Or you need to be, I would call it, A-rated or better to get those stuff. Also, what you get if you have fixed price risk, that typical tends to be margining, meaning that every week or every month you look at what's the value of the deal compared to the market. And then there's a payment, for example, if the difference is more than €5 million, so the deal is more than €5 more in the money for one of the parties, you basically get, I have to explain that to you as an exchange, but you basically get a margin call and you basically have to pay it. All those kind of things are entirely possible. If you go back to the windmill owner, he's very simple. He needs cash. He cannot give any cash. So he very simply will say, hey, you get step-in rights on my wind park if I go bust. That's all you can get. If you don't want the deal, go away. And because everyone is desperate to buy green power, that works pretty well so far. And then if you go to the industry, well, there are many different credit ratings. And always, as a consultant, advise the good credit ratings. Then, of course, you can take more risk. If you have a poor credit rating, it makes no sense to take lots of risks because the value of you taking that risk is very low for the counterparts because the bank will immediately see that's poor credit. So why then take the risk? Because if things go well, you have taken a risk. If things go bust, the counterpart had nothing to do with it.
That's
Did
a very
I give
good
you
point.
an answer?
Yeah, I have not so much to add here, but I would say it's not fundamentally different than any other contract that you have on a long term. It's a risk.
Okay, any other questions? Okay, why don't we just everyone should go to the Resource Wind event in Amsterdam in how many weeks? 2, there you go.
I'm joining, by the way.
Good to know. I didn't really want to do too much publications about it, but I did have one point. For now, those are the markets where PPAs are happening. So Nordics and mostly Netherlands, Belgium, bit of Spain. But that's until 2021 what we see so far. Because in the new Renewable Energy Directive, all the European countries have to enable PPAs and simplify them a lot. And we already see the steps in Bulgaria. We already discussed those steps in Romania. So we see Eastern Europe already doing that. So I think that's already a positive message from our side. But overall, we also think that the PPAs are going to be driven by bigger companies, exactly because of the point earlier made about that risk. And even if a bigger company goes under, then you again have a risk, and we still didn't define our position on that. But perhaps in that case, and I don't really like to say it, but perhaps the government should take some sort of a risk where they will provide some sort of a subsidy for a wind farm that ran out of a buyer from the electricity. But that's still to be defined from our side.
If I can react to that one, I'm pretty simple. If the wind farm is up and running, even if it goes bust, it will remain up and running. Because the marginal cost to keep it up and running are basically €2 per megawatt hour. That's always the value. So I really are objecting against the fact that you want the government to play a role there. Now let the market do its work.
Me as well.
Really this is really a problem which needs no government interface because it's solved by itself.
Yeah, that's what I said. It's the last resort what we would think of.
And it's exactly the reason of existence of the PPAs, by the way, to cut off the government.
Great. Final question before we wrap it up. I think we could go on. Yeah, this subject has miles and miles to go on. Final question is, across most of Europe, we're seeing commodity prices going up. The last 3 or 4 years as corporate industrials, we've been very lucky having, such low pricing. Do we think that's going to make the PPA discussion easier for corporates because they can get a long-term deal that looks, let's say, in the money compared to where current or pricing in the next 2 or 3 years is going? Or do we think that the developers will get greedy and they'll see the price curve and they'll want to maximize their situation on the price curve?
Well, I think there's several angles here. I think it's a good time to defend a PPA strategy in a company now, because I'm actually pretty amazed to see prices in PPAs compared to actual market prices. But on the other hand, of course, a PPA runs 15, 20 years. So the price risk is still there, no matter how you look at it. What we actually see as a risk is that the demand for PPAs will be a lot bigger than actually the availability of renewable energy, and that will push up the prices in the longer term. So it's important to be an early adapter. Probably.
I agree with you on that. Last word, Remco.
Okay, thanks for getting the last word. Maybe one comment. I mean, the power prices in Europe, they are on the rise. But if you compare them to, for example, USA or Australia, or China, we are still, I would say, in good shape. Meaning that, with all respect for industry, it's not as expensive as you sometimes get the feeling. Because again, in China, the price is even higher. That means that also there's more upside. And that's why I echo your comment. I think it's still a relative good time to go into the PPA. I would also give you one free advice. I'm not a consultant anymore. But the fact that you commit for 10 years, that should give you a significant discount. If you commit for 2 or 3 years, you don't get any discount. But a 10-year commitment from a well-rated company like yours, or like any of the other ones, that should be reflected in the discount, making the story even easier to sell internally.
Great, thank you very much. Remco, Rolf. Okay, so we've got 2 final presentations. Both of them are short and both of them are sweet. and both of them in their own way talk about money. So the first presentation from Salvador, who's going to come and join us from Imperial University, is looking about how you get into the practicalities of building your business case, looking at the cost of energy in the sites where you want to deploy energy efficiency investments or on-site generation. So once Salvador has told us how we can identify and build those business cases, then Miles from SDCL is going to tell you how we can fund those business cases. So the next half hour is all about actually going from nice ideas, that a lot of which we've seen earlier on, to actually turning that into investable projects which can then deliver the benefits. Salvador, please introduce yourself. I guess you want a presentation?
Yes. And I have 10 minutes, right?
Or 15.
Yeah, okay. Well, just
see how you go.
Yeah.
Please do space for questions.
Thanks. Thank you, Jason. Hello, everybody. So Salvador Acha from Imperial College. I'm an energy systems researcher in which we try to address energy and sustainability challenges for commercial and industrial customers. And I'll be presenting today a little bit these novel data sets that we're producing to drive decision making across large consumers. So we titled this piece of work Formulating and Communicating Electricity Price Signals to Non-Domestic Consumers. So just to provide some context, in the UK, the prices of electricity are creeping up considerably. I got this chart that was recently published. It's next to Malta and Cyprus, Italy, and Germany. The UK prices are quite steep. The average price of electricity in the EU was 11.2 cents euros per kilowatt hour. In the UK, it's, well, depending on how you hedge and how, the risk you're willing to take in the spot market, it's around 12 pence a kilowatt hour, which is slightly higher. There has been a 20% increase in these prices on average since 2008. That's across Europe. But then if we focus in the UK, these large consumers are expected to suffer a 52% increase from 2011 and by 2020. Now, these customers are usually billed on a half-hourly basis, but the odds of the market make it tricky enough to try to determine what these prices are on a half-hourly basis. And that is because it's a complex and ever-changing environment in which the regulator, the network operators, and also, well, the market itself is changing, so you need to be constantly updated. There is a lack of resources to properly characterize these price signals, and there is a lack of knowledge in applying them as well. So just in this chart, what I'm trying to showcase is that the commodity, the weight of the commodity is coming down considerably because the UK government has been putting tariffs to support security of supply and low carbon generation. But these bits of the bill are gaining on the actual commodity itself, coupled with investment in network high level and low voltage transmission and distribution networks. That is also creeping up the prices of consumers. Yeah. So we find that there is an industry gap in driving smart decision making. So I have the phrase of, oh, well, ignorance is strength. Nobody really understands their electricity bill because they come in on a quarterly or 6 monthly basis, and all these tariffs are lumped in a total sum, so nobody really actually knows how it was actually calculated. So the data services that we're proposing and we're developing there in the college is that in being able to represent the temporal and the spatial characteristics of these prices. Across the UK, as you can see on the left-hand side, these prices would be based as a function of your position in the UK, location-based. The DNOs have a big say on how you get billed, and also on your voltage connection. So we think that by offering these price signals, insights and empowerment to the consumer should take place to drive energy efficiency, improve energy management practices, and well, drive change and be, efficient. So how does this work? Basically, there's more than around rough. I categorize 14 tariffs in the UK electricity bill, although there's more, because some of them you can break them down further still. But basically, what we try to propose here is that for every half hour, we allocate a price to each tariff, composed of the commodity price, but then there's also some other key elements, temporal elements such as the balancing use of system charge, coupled with the network operators, which operate on a 3-tier system, red, green, and amber, as well as some capacity charges and reactive power charges. Then we combine these tariffs with the governmental incentives such as contracts for difference, capacity mechanism, renewables obligation, and then if you lump in the transmission network operators charges, the tenuos, what is called tenuos in the winter, you can start depicting, such as the figure that you see below, the pence per kilowatt hour that a specific consumer is being charged, yes? So what you can do is by presenting these sorts of visuals, it can make very easy to understand when it's the most critical times of running your operations. And these variations will occur on a daily basis and with particular differences between weekdays and weekends, as well as winter and summer periods. So insights, what are the insights that this data can provide? Well, it'll allow you to understand how your energy expenditure breaks down, spot critical cost periods. It can also help you for budgeting and billing validation purposes. We've done this exercise with a large consumer, and right now we're in 1% margin of error in the billing validation. On the pre-feasibility, it could help on the pre-feasibility of investment analysis. So that's driving energy efficiency or installing new technology such as heat pumps, batteries, etc. It could also help you, therefore, to validate your investments. Jason made the allusion that once you invest in a technology, it's very complicated to do the validation, or a lot of people don't go through it, but this sorts of data sets could help you do it easily. Then, if you want to have a long-term horizon in your perspective of understanding how prices could evolve over time, you could also do a forecasting exercise. And next is a multi-site property analysis. You would be able to understand how each site is using, how the load of each site drives the prices differently, yes? And inform a more comprehensive investment strategy. So this chart gives you an idea that you would be able to visualize the daily expenditure of the electricity costs in your site. These big spikes are the triad charges that take place in the UK in the winter. That's how National Grid recovers their revenue streams. But then you'd be able to see in monetary terms how the property is being billed, yeah? Or how are those costs composed by? And then you could you could visualize it on a monthly basis, what have you. Know that the important thing is that since it is a bottom-up approach, you can go as much as you can into the granularity of understanding what's driving your costs. And likewise, if you have different properties, in this case across the UK, you'd be able to spot the differences of how a similar type of operation, be it a hotel or an academic institution, could have incur different costs depending on where it sits in the network. And we think that this sort of information really helps inform the strategy decision or which properties you should be focusing on first rather than later when you're developing energy efficiency investments. So we've been developing a proof of concept. We've been working with a large food retailer, Sainsbury's. I don't know if you know him, but they're quite big in the UK. We have applied the concept and validated it. We are using this sort of information in their organization to drive decision making, especially for technology investment. And we have this information available via an API, so that if you're interested, you could have a trial of this information and see, what is the value to your organization. If there's anybody here with UK operations, and basically this is what we wanted to showcase, that this information, even though it's complex, you need to be constantly on the ball, trying to understand how regulators and different players are influencing your electricity bill. It is possible to quantify it, calculate it with a good degree of accuracy. It has been validated. We are independent, and it has been automated. And if anybody wants to learn more about it, well, happy to have a discussion or to answer a question.
Salvador, thank you very much. So Salvador showed me this a few weeks ago, and what's interesting is I think most of us, in terms of C&I, we have bureau service, which is basically bill validation. We sort of have that reasonably well covered, and we get some nice charts, and they tell us how much money they're saving us. What I like about this is it takes it down to the per site level. So I think if I'm right, you postcode base the and the meter. So yeah, they take them MPAN in the UK or whatever. And as we start getting more granular, looking at how we make investment decisions, energy efficiency, on-site generation, where to locate a facility, it does need to be down at the postcode level because, or even the MPAN, because that will fundamentally change our energy costs. And as we move from a world of, let's say, TSOs, or so transmission grid level, to regional DSOs, we're going to see that actually the costs are going to be allocated down to those regions, in my opinion, increasingly so. Yeah. So Salvador, thank you very much. Any questions on this?
Yes. If not, you can catch me later. I'll be over there at the end. Yes? All right. Yeah.
Well, 2 seconds. Let me find your...
Hello. Adrian Ramos from Omrum. My question is related to the location of our generators. Are you taking into account the generators for computing the price of your location?
No. This is more from the consumer perspective. If you're a large energy consumer, it's a way to calculate your energy bills. The generators themselves, we do not go into that. We just take the spot market price. That is what the consumer would.
Do you mean on-site generation?
I mean that could be one, but the thing is that at the end of the day, the same way you are consuming the electricity from a certain point in the grid, the generator will be paid depending on the point he's feeding the grid into as well.
Yes, but when we operate with a day-ahead market, you can estimate the prices. Nord Pool provides the forecast of prices for day ahead. So it's already given depending on the fleet available to meet the demand in the UK system. So it's not, it's a blend, it's a market that already is taking place, and it's irrespective of one single generator.
And I think anyway, most corporates will have their own individual supply arrangements, whether they're buying wholesale, so it could be the forward pricing, or they're buying long term. So,
yeah.
Okay.
Thank you.
Great. So, Salvador, thank you very much indeed. So it's always terrible being between the audience and drinks, but I am almost certain that Miles can ably bridge the gap, and the reason is because he's the money man. So I should just press it again. It should come up automatically. There you go.
Great, well, thank you very much. So I'm Miles Alexander from Sustainable Development Capital. We are headquartered in London, and we develop and finance energy efficiency projects. So we've been backed by the UK government, the European Investment Bank, and other institutional investors. We have teams in London, Dublin, New York, and also Singapore. And we are backed by a number of long-term institutional investors. So what we focus on is around energy efficiency, distributed energy generation, and also smart grid. So when we're looking at energy efficiency, we're looking at things like lighting, building management systems, heating, ventilation, air conditioning. On the distribution, decentralized generation, it's very much around combined heat and power plants. We've worked particularly closely with a local Austrian company called GE Gembacher on the combined heat and power plants. And then we work looking at storage as well. It's another big area for us. But all of these are around developing and financing energy efficiency projects. These are some of the clients who we've worked with. So I'll go through later on in some more details about these individual ones. But these are kind of the portfolio of investments which we've done in the UK. And then globally, we've worked in New York with a couple of institutions and opportunities, also with Tesco's and a big supermarket in Ireland, which we project there, and then with Panasonic in Asia. So energy efficiency, why is it so interesting? It's because it's free. Basically, it's money being wasted by companies now, where they're paying high energy bills than they should be. If they would put in better equipment, they'd be saving a lot. If you look at lighting, you can get up to an 80% saving by taking out fluorescent tubes and putting LED lights. And that will have obviously a bottom line impact. So it's around financial performance of companies. It's also around their environmental performance, their sustainability goals, which are creeping up the corporate agenda, being more and more important. And the third area, which we're finding is particularly important in the UK and also in the northeast of the US, where there's concerns about grid power out. Where there's stress on the grid, there's more and more demand through electrification of transportation. We've got also, looking at the UK, you've got 9 gigawatts of coal coming offline. That's being replaced by intermittency through renewables. It's about 50% of generation of power in the UK now. But people want to have a core base load, and that is often at jeopardy if you're reliant on the grid. So hence distributed generation being more and more important for manufacturing companies. So what we do is bring together a solution which working hand in glove with the host company or public sector entity. We bring the capital, but also we bring the technology partners. So working closely with GE or NG or Siemens or Philips, depending on who the technology provider is for the need of that particular company. And normally it's a portfolio of solutions. So it'll be a mixture of lighting, HVAC, it'll be generation as well, could be solar, could be wind. And it's about implementing that project. So we deliver their regulatory compliance, important for more and more companies, with reporting, not just to government, but also to stakeholders. Also about the energy savings and about that infrastructure, the improvement of their infrastructure. So one of the assets which we invested into was really around improving the safety of employees and customers into the area with enhanced lighting and improving the customer experience as well. So what the benefit is for customers is they don't have to put up any capital. We'll finance it. We'll give them a share of the savings. So you can see from the left-hand side that chart where it's a 7-year project. We give from day one a saving back to the host company. And also you're taking away the risks that they face. So whether it be around construction risk, whether it be our implementation risk or operation and maintenance. And we do that through having an energy service agreement with the host company and obviously having an EPC contract, an O&M contract with the relevant provider of the technology. If we look more widely at the actual market, so the CHP market, this is just taking an example for the UK, but here if you look on the right-hand side, you've got the scale of the percentage used of generation from CHP relative to the overall generation of power across a host of different countries. Austria is actually just towards the average, around 16% of generation is from combined heat and power, so distributed energy generation opposed to coming from the grid. The UK is only about 6%. To the extreme right, you've got countries like Latvia and Scandinavian countries where they have a very high level of generation of CHP. But we're seeing this forecasted for the UK and other countries to be increasing. So the UK generates about 6 gigawatts of power from combined heat and power plants. That's going to be increasing by threefold, up to so another 15 gigawatts of power coming online, which will give a lot better opportunity to companies to have that decentralized generation, control over their own power, and potentially having their own private wire of development of energy, which they could oversize and generate for third parties as well. Lighting, similar growth trajectories there. If you go back only a few years ago, it wasn't really the norm to do LED lights, whereas now it very much is for companies. If you're going to be doing anything around lighting, you're going to be doing LED. and we're going to see that forecast to growth quite dramatically over the next couple of years as well. So I think in conclusion, over kind of the two key areas for us around CHP and lighting, but generally for many other sectors as well of technologies, it is a very attractive market to be working in, to be developing and investing into, and getting better solutions for host companies around their energy dilemma. Just quickly walk you through a few case studies. So this was for Citigroup, based in London, and it's their data center where they're processing a lot of data for themselves, but also for third parties. They wanted to reduce their energy costs, but also make sure they had higher security levels around the generation of power. So we put in place, working with Clark Energy, who's a distributor for GE Gembackers. It's a combined heat and power plant solution, but also cooling. And we basically installed a 2.8 megawatt plant for Citigroup at their data center in order to be able to reduce their costs, but also give cooling, which is becoming more and more important for data centers who are taking on more and more demand of energy and will need greater cooling levels, but also have independence from the grid. So it's not necessarily putting one CHP there, it's putting multiple CHPs in order to be able to guarantee the 5 nines of security on supply. It's in Bartholomew's, so it's a cancer hospital in London. Again, we put in place CHP. Their rationale was also around carbon savings. It's very important for them, but they did both through energy savings and carbon savings by putting in place a CHP 1.4 megawatts in size. So it's just two examples of generation, distributed generation. A couple of examples on lighting. So this is Santander's branch network across the UK, just over 790 branches. And what they were driving at was really to get enhanced lighting, better lighting for their customers, but also for their staff working there. We also installed building management systems, heating, ventilation, air conditioning into their 14 offices. So they wanted to have carbon savings, so saving 7,000 tons of carbon a year. And also the other reason for doing this is around operation and maintenance. So they reduce on having staff going in or employees going in to replace the light bulbs and disturbing the branches. This was the last case study I'm going to share with you, but this is on national car parks in the UK. You can see a very clear difference between the before and after impact of lighting. The driver for national car parks was actually about revenues, because women were scared to go into car parks at night, because if you go on look on the left-hand side, dimly lit, they didn't feel safe. So to put in new, more efficient lighting, they really found that they felt safer, so they were going into car parks at night, and that enhanced their revenues, and also obviously saved them money around the carbon savings and energy savings. So that's kind of a quick snapshot of what we've been doing. If anyone's got any questions around energy efficiency, financing, or doing projects, then love to hear them. Thank you.
Well, I've got questions. grab a microphone. Is there one around? And
yeah.
Come sit down. So it almost sounds too good to be, too true to be good, too good to be true. In the sense that, we come to you with an energy efficiency project, you finance it, and Bob's your uncle. Obviously, it doesn't work like that, because if not, we'd all be doing it today. What are the good ways and the less good ways about how we use external financing in order to help fund those projects that we just can't get across the line internally in our own organizations?
Yeah. So often the challenge for doing energy efficiency projects within companies is around the corporate cutoff on paybacks. And so a lot of people are looking at, okay, corporate, we're going to do 2 years or 3 year projects, we'll do ourselves. The rest of the projects we won't do. So that leaves kind of low-hanging fruit is easy to do within the company. It leaves the harder ones for third parties to do. To do those projects, you really got engagement from both sides, between the developer, financier, and with the host company. And so the host company needs to allocate somebody in order to be able to work with us to develop and do the project. And you shouldn't look at it as being capital coming in, because too many companies look at it that way, and so they think, okay, well, we just need cheap capital in order to be able to get it done. These projects are actually fairly complex. It's not just a matter of going in and switching a light bulb. You need to have a whole deployment plan. You need to be partnering with the right technology provider, because otherwise you end up installing equipment that may not be appropriate. In branches, relatively straightforward. If you're looking at other areas where there could be certain humidity levels that are very important, or a light intensity that needs to be supermarkets, for instance, to be able to direct onto fish and things like that, it needs to be a proper intensity in order to be able to make the customers attractive to those products. So it's a mixture of challenges. I think it really is a partnership between the developer, financier of the project and the internal company in order to be able to say, we want to go ahead with this, and it's a program. Because it is a slight evolution between doing the easier stuff, but also doing the harder stuff, which could be putting in CHP, but also doing solar, putting that on rooftops. And then if you look, earlier discussion around the steel industry, looking at pumps, variable speed drives, motors, it's really anything that is generating and saving energy, but also saving costs for companies in order to be able to get that done. But it's not straightforward, you're right.
Okay, and we're talking about the complexity of delivery, because if you take, for example, on-site generation, in effect, we're outsourcing, so to speak, the delivery risk to an organisation, an ESCO or funding organisation like yourselves. Does that mean that you don't just simply take a project as designed by the client? You look at that project from a perspective that you've got to deliver on that. So do you see that a project that you may be, let's say, given, so to speak, does it stay the same or does it evolve before the end solution?
It will evolve, and it will be tailored to what the best practices we've seen, but also it's very much got to be the project that's wanted by the company. So whether it's building a new energy center for a chemicals company, it's working hand in glove with them, because the last thing you want to do is install something that's they're not going to want in the end, but it's because we own the asset. So it's got to be something that works from both parties, but heavily influenced by the host company on what their requirements are.
Okay. Any questions from the audience? Please introduce yourself as well. Yeah.
Could you elaborate a little bit on the EPC concept?
Sure.
Which organisation are you from?
Sorry?
Which organisation?
From Malaysia, TMB.
So on the EPC concept, the engineering, procurement, construction, it's one part of the contracting. So it's tends to be with large utilities or specialized EPC contractors. And basically the contract is ordered to deliver the project. We'll have the contract with the host company, and we will be supplying those services to them. But we're a relatively small firm. We don't have the might of some of the big utilities in order to be able to develop that. At the same time, we'll bring in different technologies. So it could be around CHP, it could be around lighting, could be around HVAC. But we'll put in place an EPC contract more to be able to make sure we meet certain hurdles and technology provisions, and limiting the risk around the deployment of that project. And that'll be a contract will be in place for the construction period. After that's done, then we'll move into an operation and maintenance contract with normally the same company. But if they can't do it, then we'll work with a third party in order to be able to deliver the project.
Okay, Mars, thank you. Any other final questions before we rush off and quench our thirst at one of the many bars? Okay, great. Miles.
Thank you very much.
Oh, sorry. You're not going to get off that easily.
Thank you. Timons at Trinity Street Asset Management. Quick question, just on, you mentioned some of the kind of carbon savings you were able to facilitate for someone like Santander. I mean, given what's happening in kind of carbon pricing and potentially in the future post MSR, I mean, how big of an opportunity is that, and how much of a focus is it for customers who you speak to currently? Thank you.
So the number one focus is cost. And then I'd probably put after that is around carbon, but it's not around carbon pricing. It's more around their investors and what they're projecting as an image to their clients as well. And that is very important. But number one is definitely around savings. Third one is probably around security. I think, looking at some chemical companies we've been working with and pharmaceutical companies, they look at security of supply as their top priority, because if they have a brownout during the generation of their products, then that can directly impact their costs. So they're looking at it from security of supply. But carbon is important. I think it's going to be growing in importance, and that's because long-term institutional investors investing into large companies are concerned around the green impact. And you look at the reports that come out recently, more and more of the public sector, of the public are concerned about it as well. So I think that will be growing in importance.
Okay, great. Well, in interest of one side note is the big difference to me as a corporate and industrial in using, let's say, external funding support, such as an ESCO like STCL, is that you're not constrained by budget cycles. We're constantly hitting budget cycles because we're a January 1st, so we get to September, we have to put it in the budget, then we start the project as quick as we can in January to get as much of the benefits by the time we get to June or July, and then the whole thing starts again. Whereas I think one of the big opportunities, and it's probably undersold somewhat, is that in effect you're not working on a budget cycle per se. So therefore, as soon as we can get the projects and done, we can fund them and get on with it. Anyway, a bit of a side note. Miles, thank you very much indeed. Thank you for being a great audience. I like white wine. Feel free. And we look forward to seeing you around over the next day and a half. And come say hello and introduce yourselves.